In this lesson, we will learn how to work with chi-square distribution and how to compute probabilities related to chi-square. I would like to remind you that chi-square distribution is different compared to the normal or t-distribution we worked with in the past. The normal curve and the t-curve both were symmetric. Chi-square is not. It is skewed to the right. It can become less skewed with higher degrees of freedom and more skewed with smaller degree of freedom. One more characteristic that is important to note is that all chi-square values have to be either positive or zero. They cannot be negative. In other words, if I look at this curve that you see right here, this point right here is the smallest possible point chi-square value could take, and this point is zero. And then chi-square values can only grow and become bigger as we go to the right. In a way, you can look at it as this point being the location where x and y axis meet, and this therefore must be a zero. So this should be assumed when you work with chi-square distribution. The problem before us has three parts, so let's take a look at one of them at a time. Suppose that chi-square follows a chi-square distribution with 11 degrees of freedom. Compute P of chi-squared less than or equal to 15. Round your answer to at least 3 decimal places. Remember, please, that when you look for probability, when you try to compute the probability, you are really computing the area under the curve within the specified interval. And my specified interval this time is all chi-square values that are less than or equal to 15. So I estimate where the 15 could be. Let's say it's here. I want to find the probability, which means area under this curve, less than 15, to the left of 15. Well, remember, it means it's bound by 0 on the left side and by 15 on the right side. So I'm looking for the area under the chi-square curve between 0 and 15. Well, my calculator has a function, chi-square CDF, under the distribution menu. So choose this function. I will demonstrate how to do this on a slide in a few minutes. And you enter your lower bound, upper bound, and degrees of freedom, which in this case is provided to be 11, and press enter a couple of times to get this quantity of 0.818 rounded to 3 decimal places as requested. My second part says, suppose again that chi-squared follows a chi-square distribution with 11 degrees of freedom. Find k such that probability of chi-square being greater than k is 0.1. Round your answer to at least 2 decimal places. So I'm looking for p of chi-squared being greater than k equal to 0.1. What does that mean? How do we understand this statement? Well, please remember that probability means area, and this probability happens to be 10%. So I would like to know some chi-square value that separates 10% of area where to the right because of greater than. So I want to know this boundary point that separates 10% to the right from 90% on the left. So I would like to know this location. Well, typically, when you worked with normal curves or t-curves, when you knew area and you had to find the corresponding z-score or t-score, you had to use the inverse norm or inverse t function. Unfortunately, the calculator doesn't have inverse chi-square function. It has the chi-square CDF function, but it doesn't have an inverse. Well, we can find a way around this problem by using another function on the calculator called Numeric Solver. It's like an equation solver feature. So we're going to go into Math menu and scroll up, and the last thing at the bottom of the list you will see is called Numeric Solver. You are going to choose this option, and I will demonstrate how to choose it, how to use it exactly in literally a few minutes. So wait for a second here. But let's write down the equation. What are we looking for? We could use the knowledge that chi-square always starts at 0 and goes up to some positive value k in this case. So I would like to find out the solution to the following equation. If you have a function chi-square CDF and you're looking for the area between 0 and k with 11 degrees of freedom, that area should be 90% because the other area to the right of this unknown value k is 10%. So I'm saying when 90% or 0.9 results as chi-square CDF function computed between 0 and k with 11 degrees of freedom, what is this mystery number k? The numeric solver will allow you to set up this equation and produces k value of 17.28. Let's see how it's done on the calculator now. Now let's take a look. We go to second vars, choose option 8 chi-square CDF, where we will have to enter the lower and upper boundary of the interval within which we're trying to find the area. Under this curve, enter degrees of freedom, 11 is the correct number. Press enter a couple of times to get the answer. To do the second problem, we're going to use the numeric solver feature. So let's see how that one works. Math, scroll up once. At the very bottom of the list, you'll see numeric solver. You need to enter this equation. So left-hand side, 0.9. Press enter to go to the right-hand side. Now I need to enter chi-square CDF function. So go back to second vars, option 8, and enter the values. A lower bound 0. Upper bound is unknown value x in this case. I could type k, it's too complicated to look for k. It's just easier to use x on TI-84. Press enter, but always press alpha enter when you are done to force your calculator to recalculate, because every time you just press enter once, it remembers some past numbers from previous problems. So you must press alpha enter to get the most current information or the solution to the equation you see currently on the screen. The equation 0.9 equals chi-square CDF between 0 and x with 11 degrees of freedom. The x, the upper boundary, is 7.28, and that's what the answer is right here. Now it's time to look at the last part of this assignment. We are asked the following. Find the median of the chi-square distribution with 11 degrees of freedom. Round your answer to at least 2 decimal places. What does this mean? It means I would like to find the point, the value chi-square that separates lower 50% from the upper 50% of area under the curve. It means that under my curve there is some point k that has 50% on the left and 50% of area on the right of that point. We use the same numeric solver function on the calculator with the exception of changing the 90% to 50%. I'm looking for some upper boundary value k. Let me highlight this. Here's my 50% of area right there. So I am looking for chi-square CDF function that computes the area to be 50% between 0 and value k with 11 degrees of freedom. I'm going to use the same function on the calculator once more. You go to Math, scroll up once, choose Numeric Solver, and all you need to do now is just change 0.90 into 0.50 and press Enter. And don't forget alpha enter to force the calculator to actually recompute and give you the most current answer of 10.34 when rounded to 2 decimal places.